Alright guys, so let me ask you this. If I was going 60 mile an hour for, oh, let's say this, sorry. Let's say I went 60 miles in 2 hours, and then I went 90 miles in 1.5 hours. Can anybody tell me, can you figure out what my average speed was for the whole trip? Now, how are you getting that? Add what now? Be more specific. Yeah, so. Oh, I see. No.
Wait, what did he say?
Yeah, you have to somehow take the time into account, right? How do you calculate how fast something's going? If I tell you how far somebody went and how much time it took them, how would you calculate how fast they went? Just divide, right? So how far did I go total? I went 150 miles. And how long? 3.5 hours. That'll tell you the average speed. You can't take speeds and average them, because I think somebody over here pointed out that loses how long you were going at that speed. Cool. One of my favorite things is if I had to go, if I went halfway to a place, if I got to go to my friend's house, and halfway I'm going 40 miles an hour, how fast do I have to go the rest of the way to average 60 miles an hour? The answer is not 80. Because then I would have been going slower for longer. So somewhere you got to take the time into account, right? Yeah.
This is 150 for this
I'm sorry?
Is it for this question?
Yes, this is the all one question, yeah.
No. It is more than this, because for 2 hours, 60 miles, 120 was 135 for 1.5.
No, just I went purely 60 miles in 2 hours. I changed my opinion. I first had a rate, and then I thought, no, that's not what I want to do. So that's my mistake, yeah. So 60 pure miles in 2 hours. So how fast was I going in the first place? 30 miles an hour. So I'm going through construction somewhere. I'm hating life. 2 hours of, or I'm just driving the wrong way on the 8 at the wrong time of day. And then 90 miles in 1.5 hours. 60, yeah, cool. So I kind of picked up, good. Still not going as fast as I want to probably, but hey. So what does this come out to be? 300 divided by 7, yeah, 40 something or other. 42.86?
Yeah.
All right. Not what you would necessarily expect. Which one of these, I mean, if you just average those, that's obviously going to be very wrong, because that's not the real. Now this is 30 miles an hour, and we said this was, what did we say this was? 60 miles an hour, thank you. Directly in between those two is what? 45, and actually it came out to be a little bit less because I'm going at this speed longer. You guys see that? It's going to be closer to the speed that I was going at longer. Yes, ma'am.
For problems like this, would you want us to round up to like 40, 30 miles per hour?
Yeah, when in doubt, go a couple, but normally they'll either tell you or I'll tell you.
Okay.
When in doubt, go a couple of places. Not quite science class. If you're taking any science classes, you've got to be very careful about it. Sig digs, yeah. Right.
Significant figures.
Significant figures, I like that. Wait, in science it's sig figs.
Yeah.
In math it's sig digs. Significant digits. We got to be different.
Oh, wow.
Yeah, I know. I like the Jets and the Sharks. What's that sort? No.
Really good. Huh?
So how's that? Is that so far so good?
Yeah.
Okay. So let me show you what this looks like kind of visually with a different problem. Same idea. So if I start here and I go in 2 hours, I go 40 miles, and then in 1 hour I go 10 miles. Well, that really sucks. Visually, the average comes out to be just the as the crow flies kind of thing. Tell me why that makes sense kind of visually. The slope of this purple dotted line, how does it relate to the first part of this black line? The slope, which one's bigger, the black line or the purple line? The black line's bigger. Over here, which one's bigger, the slope? The black line or the purple line? Purple. So what the purple does is it averages out those two slopes, right? So this is geometrically what this problem is algebraically. How are we doing so far? Is that semi-understood? So if I have a, here's where I want to go. I want to get away from the purely physical example and get to a purely graphical example. If I know that a function, oops. If I know that a function is, there's a sentence there somewhere. Here, and then it goes here. What's the average? I'm not going to call it speed necessarily because it's not necessarily miles and hours or distance and time. What's the average rate of change? All you got to know is it started here. At 1 it was at 2, and then at 4 it was at 3. That's what I'm trying to say there for those of you that aren't as tilted as I am. You guys with me? So how do you figure out the average rate of change?
1 over 4.
Yeah, how much did it change the outputs? Yeah, it's just the slope, right? That's all it is. So here's the straight as the crow flies, well, sort of. Oh, that's not much better. So it'd be 1 over 3. 1, 2, 3. So 1/3. Now that's, did I draw in there what the function is actually doing from one point to the other? Of course not. The function could be going like this, could be going like this, it could be going like, woohoo, ha, ha. Well, it can't be doing that, but you get the idea. As long as it's actually a function, it doesn't come back on itself. It's not go crazy. All right. Notice something though. I want you to, if you come back to like slope, if you come back to slope, if you come back to speed, here's going really fast, kind of like down, and then it's going faster than this up, and all these little slopes kind of average out to be this. That's the idea. Since it starts at the same point and ends at the same point, the same point as where this does, the straight line, all the slopes as they go along kind of average out to be the same as that purple line. So the be-all, end-all here is, I don't care what the function does in the middle. All I care about is where does it start, where does it end, apply the slope formula. That's what average rate of change is. This whole idea is going to become huge for anybody going into calculus. All calculus does is it gives you a way to figure out the slope of a curved line. Algebra, we only can do the slope of a straight line, right? That's pretty damn boring. It's 3, or whatever. But of course, when I have a slope, when I have a curve like this, the slope is constantly changing. So calculus actually gives us a function that tells me what the slope is at any point. Here it's negative. Here it's positive. Here it's 0. That's kind of cool. But that's all calculus does. It's actually a huge step, but it's not a big step away from algebra. It's the same slope formula, really, at the beginning. Okay. How many guys are going into calculus after this? All right. You'll see when you get there. You're like, oh shit, that's just what Jeff is saying. There's a slope formula with some other weird shit thrown in there, but still, it's just the slope formula. So, I mean, this section is nowhere near as weird as it might sound at the beginning here. It's just when they give you a function like this, they say h of t is t squared plus t. Find the average rate of change. over, let's see, how do they say it? Oh, they're even nicer than I would be. Let me really give you what the formula would full out look like here. Average rate of change would be H. Now, which one do you think I'm going to subtract from? Am I going to do this minus this or this minus this? Of course, I didn't really give you a good. Is it A minus B or B minus A? B minus A. I'm assuming it's going in that direction, right? So it's got to be final minus initial to see how much it really changed by, right? Okay, so it's going to be H of 4 minus H of 1. That's the outputs, right? You with me? That's the outputs. That's the Y values divided by the inputs. And the really cool thing is, it's 4 minus 1. You can kind of see it there, right? Because what do the T's do? They go from 1 to 4. Isn't that the slope formula? Y2 minus Y1 outputs over X2 minus X1 inputs. Nothing new there. That'll be one of the first things you guys talk about in calculus. And then what do you get there on the top? What's H of 4?
20.
16 plus 4, 20. What's H of 1? 2. And then 4 minus 1. So 18 divided by 3, 6. So if I were to draw this and plot those points and connect them with a straight line, that straight line would have a slope of 6. I love it. That's the whole idea right there in a nutshell. Right? That's why the math is so easy, because it's just a straight line slope. Y2 minus Y1, X2 minus X1, no big deal. Okay, maybe. Some of you guys look unconvinced. Let's see. I'm hoping you guys are cool with if they give you a function, if they give you a picture, and they say, what's the average change from here to here? This is 1, 2, 3, 1, 2. How do you figure out that average rate of change? Yes, ma'am.
Just on the slope?
Yes.
So,
Just draw, if you want to, draw on the line. Yep.
Up 1 over 2, so half.
Yeah, it goes up 1 over 2. I mean, you can't beat that. If they don't give you the picture, you got to do a little work because you don't have the outputs yet. That's this work here. You just got to figure out the outputs. You don't have it. You don't have it on the graph. You just got to throw it in the formula and see what the outputs are. So you can do Y2 minus Y1. Don't make that more than it is. Nothing major there. Yes, sir.
Can you put that step again?
Which steps? From here to here?
The one.
So if they give me the function and they want to know what's the average rate of change for this, I know that my inputs change by 3 already. I know that. So I know X2 minus X1 is 3. I can see that they change by that much. To finish out the slope, I need the change in my outputs. So I have to know what my outputs are. So what's my output at 4? 20. What's my output at 1? 2.
How? Why?
Because here's my function. Right? If you throw a 1 in there, what do you get? 1 plus 1 is 2. 4 squared, 16 plus 4 is 20. Cool. So they either have to give you the graph. They don't have to give you the function then, because you can see the points. You don't need to know, you don't have to calculate what the output is. You can see what the output is. Or they have to give you the function if they don't give you the graph, because then you can calculate what the outputs are. And it's still just y2 minus y1 over x2 minus x1. Yeah?
So that's the given function and not like the formula for the rate of change? Or?
This is the function that I'm working with. This is more the formula for the rate of change. Yeah. Rate of change is just slope. Cool. How we doing? So just to really show you, slope is y2 minus y1 over x2 minus x1. Average rate of change, just to make it official, still is y2, but what is it going to be in general? A function evaluated at some point. There. So now that's official. That's the average rate of change formula. Is it always going to be x? No. It could be t, whatever the input variable is. You know, always going to be f? No, just whatever the function that I'm working with is. But that's the general formula. We see if we can go the next step with this. Let's look at the same thing again. Let me give you two little things to try on your own. You're going to love part two. Part two is no numbers, right? Just variables. T is a to t equal a plus h. You'll have exactly that kind of problem in the homework.
Section 201. What section?
This is section 2.4.
2.4.
Yep. It's all about how much do the outputs change while the inputs are changing by this much. That's the whole idea of the average rate of change. Just like the average speed would be how much did my distance change divided over how much time. Same exact idea. So it'd be h of 5 minus h of -2 over 5 minus -2. What is h of 5? 30. Cool. 5 squared, 25, plus 5, 30. And what's 5 minus negative 2? I mean, sorry. I left this guy out. What's h of negative 2? 2. All right, negative 2 squared is 4. Minus 2 is 2. How we doing? Over 7. Yeah, 28 over 7. 4.
How you got the 30 again? Sorry. How you got the 30?
So the 30 was h of 5. So h of 5 would be 5 squared plus 5. Just plugging a 5 in. Yeah, so here's my function I'm working with. Cool. They have to give me a way to figure out the outputs. Either they give it to me on a graph, or they give me the function, and I can figure out the outputs. Either way. Okay? And think about it. What this says is for every step it takes, it goes up by 4. Right? So at negative 2, it was at 2. 7 steps away, that'll be 4 times 7 is 28. 28 plus 2 is 30. I mean, that's, of course we expect that. That's how we came up with 4, but that's just kind of working backwards to see why it makes sense. It did overall take 4 steps for every 1 step on average. Of course, it did that like, you know, squiggly all over the place, but still, that's the average it did. What about number 2? That's the one I obviously have a bit of a predisposition to. This would be h of a plus h. Of course, I was a little evil there with a couple h's, but oh well. Minus h of a over a plus h minus a. So on the bottom, it's just going to be h. Cool. What's h of a? Let's start there. A squared plus a. What's h of a plus h? I got you. Okay, let me let you guys soak that in. Yeah.
Back on the first one where it says h of 5 minus h of negative 2.
Yes.
Isn't that supposed to be just 2?
Oh, it's negative 2.
Yeah, and you're supposed to put it in that formula again.
Oh yeah, and it is just supposed to be 2.
Yeah.
Definitely, and it is just 2. And that's a minus from the formula.
Then why is that negative 2?
That's a 2.
No, but
What are you plugging in? What's the input? From negative 2 to 5, right? Cool. So the output is 2. I agree with you, but the input is still negative 2. That's what they told me. Good. They being me. Is everybody cool with this? Right, to get it, you just throw the whole a plus h in, square it plus add it to itself, square a plus add it to itself. The one mistake a lot of people make is they forget to minus the whole damn thing, right? The negative's got to go through to both. Let me take this over here. So now the only ugly part really is this thing, really. What do you get? A squared plus, good, 2ah plus h squared plus a plus h minus a squared minus a. How we doing? Notice something very interesting. I can't divide everything by h, but what happens to everything that doesn't have an h in it? They cancel. So up here I get 2ah plus h squared plus h over h.
Yeah, you lost me.
Now trust me, if you're going into calculus, try to make a point on your notes page. Say, we did this shit in pre-calc. When you get to calculus, you open up to that page and you're like, oh yeah, there it is. It's the same shit. Because this is step number 1 in calculus. What can I do here now? Cancel the h's. So this loses an h, this loses an h, this loses an h divided by h is 1. Sweet. So every single problem that's like this, that will happen. Every problem like this, that will happen. Especially for the functions we're looking at. Just following over.
Just go over the end part again.
Sorry. Oh, from
Kind
here
of,
to
yeah.
here?
Kind of. Well, I mean, I think I got.
Yeah, this foil right there, right? Foiled out, and then everything else is the same. take the negative through. Now cancel everything out, right? A squared minus A squared.
There you go.
A minus A.
Okay, yeah. Alright.
And then everything else has an H, so they can all lose an H. Because I'm dividing by H.
Okay.
Oh, H. Alright, so let's take a break. Let's come back. 2:15. And we'll keep on going. Oh yeah, I'm gonna give that out. Probably after the break here.